All right. Hey, everybody. So we're going to be doing our Unit 1 test review today. If you guys take a look at DeltaMath and kind of scroll down, this is a pretty hearty review here. All right. We're going to be taking 2 days to go through this review. So don't, stress too much about it. I have an example going over basically every problem here. And just to kind of give you the breadth of the work here, we're going to be basically going from chapter 1 to the chapter 3 stuff we've been doing most recently with dilations. All right. So almost everything we've learned. All right. Though it's going to, focus on the highlights as we go through this. Okay. So yeah, when we do these problems, the class examples, those are the ones we're going to do together. Make sure you're doing them with me and trying them out. After I do a class example, I highly recommend pausing the video and then trying the section right after it, which is, the same type of problems. Okay. So please pause this video and bounce back and forth between me and your DeltaMath. And then if I'm ever going too quickly, also, feel free to just pause the video. Okay, so to kind of get you going, I don't have a class example for this first section, but when you guys go to this, these are the problems that are describing a segment or multiple segments, giving you values, and then asking you to find basically one of the missing segments. These problems, I think, are fairly straightforward. The one I'm going to do on the next part is the same type of problem. The only difference is that the values are just a little bit more, complicated. Okay, so it's the same type of problem. I'm still going to draw this segment, and then we'll go from there. Okay, so yeah, on your paper, go ahead and do this with me. So first things first, they're telling us we have point R on segment QS. Okay, so first thing, go ahead and draw yourself a segment. All right, call it QS. All right, they're saying point R is on it, so somewhere right there, go ahead and do that. This is the way you'll start all of these problems. Draw what they're describing. It makes it so much easier. Okay, so now first thing they say is QS is 2x plus 2. I can see QS is this entire thing, right? So that whole thing is a 2x plus 2. Next thing, QR is a 3x minus 5. So right here, 3x minus 5. And RS is 5x minus 5. After you get this drawn out, it is a lot more clear what we need to do. We can now make an equation out of this. If you guys remember, the idea is that this small segment plus this small segment equals this big segment. All right, the whole thing. All right, so that's our equation. I said it already, but drawing this is almost a necessary thing. It's really difficult to answer this question without a drawing like this. Okay, so let's make our equation. So I know 3x minus 5 plus 5x minus 5. Those segments added together equals the entire thing, 2x plus 2. Okay, and then from here, I can start solving for x. Again, I'm going to go through this pretty quick. If you need to pause while I do it, feel free. All right, so 3x and 5x is an 8x. Negative 5 and negative 5 combine to get a negative 10. Over on the right, I have a 2x plus 2. Next thing, I see I have variables on both sides. I'm going to choose to subtract the 2x from both sides. So on the left here, I now have a 6x minus 10. On the right, those are gone. I got a positive 2. And now I've got my two-step equation. I can add 10 to both sides. I'm just going to do that in my head. Okay, when I add 10 to both sides, these are going to cancel, and I'm going to go 12. Divide both sides by 6. X equals 2. All right, here's the thing, though. If you guys take a look at the directions, they're not asking us to solve just for x. They're asking us to determine the length of QR. All right, and this means plugging it back in. QR is this one right here. All right, so I'm going to plug this guy back in for x. All right, I'm just going to do it off to the side. So maybe I'll do it up here. So 3 times x minus 5. Now I know what x is. It's 2. Okay, so doing some easy math, looks like I got a 6 minus 5, and it looks like my answer is going to be 1. Okay, so that's what you want to put into the box here. All right, so now that you've seen one of these, pause the video, try some of these out. If you still struggle with solving equations or just writing out the equations, any part of this, call me over. Let me help you out. All right, so let's keep moving on. So going on to the next thing, our coordinate distance, all right? Or in other words, finding the distance is us using the distance formula. Okay, so one thing on your piece of paper, right? Go ahead and get the distance formula. Did I pass it? There it is. All right. So there is our distance formula. All right. It's been a little while since we've seen this, but this isn't too shabby. So we're going to try one of these out. So if you want to pause and copy that. Okay, so on this problem, we have our coordinates. We're trying to figure out the length of this segment or the distance between the coordinates, and we just need to plug these into the distance formula. All right. What you probably want to do is let's recopy these coordinates. I'm just going to put them up here. So -6, 7, and -3, 0. All right. If you guys remember, the big thing I recommend is labeling your points. This is my first x and my first y, my x1 and my y1. Okay, this is my second x and my second y, x2, y2. Okay, now I will know they're going in the right spots in my distance formula. Okay, so d, we'll use d for distance, equals the square root. Okay, you should already have, the formula written down in your notes or on your paper. All right, but first thing, x2 minus x1 squared. All right, so let's see, x2 is a -3 minus x1, which is a -6. Remember, there's that built-in minus sign. All right, and then plus doing the same thing with my y's. y2, 0, minus y1, 7 squared. All right, from here, it's just a matter of just doing some fairly simple math. A lot of this can be done in your calculator. So double negative, we know, turns into a positive. -3 plus 6 is 3. And then 3 squared, 3 times 3 gives me 9. Okay, I'm doing multiple steps in one. If you're more comfortable doing those two things separately, like doing this math and then squaring, you can if you'd like. Okay, over here, 0 minus 7 is a -7. -7 squared, -7 times -7 is positive 49. Okay, and then from here, just doing this math. So 49 plus 9 looks like I'm getting a square root of 58. Right, and then from here, it's just typing in the square root of 58. Just make sure you remember how to do it. I'm doing it in my calculator right now, and I'm getting 7.61. I'm double checking DeltaMath and seeing how they want me to round. They want me to round to the tenths, which is what we normally do. That's one decimal place. All right, so just so we can all see this, I'm getting 7.61 in my calculator. All right, this is the tenths. Does that stay a 6 or does it round up to a 7 is the only question, and it's all dependent on this number, right? If this was a 5 or more, it would round this up, but it's not. So it's going to stay as 7.6. Okay, so yeah, go ahead and type that in. Okay, so yeah, again, pause the video, try out some of these distance formulas. I mean, in my opinion, this distance formula and the last problem we did with those equations are probably the trickiest problems on the entire test. Okay, so if these are, overwhelming you, that's okay. It gets easier from here, but I really want to make sure everyone knows how to do this. So please pause, try them out. Okay, cool. From here, we're going to get into doing, let's see, the next class example, midpoint formula. All right, quick reminder, here is the formula for midpoint. Really straightforward. We add our x's, divide by 2. We add our y's, and divide by 2. Okay, so don't overcomplicate the midpoint formula. So let's go ahead and do it. By the way, make sure all of this is in your notes. Make sure you're using your notes from chapter 1 and that you have them. You can use them on the test. All right, so I got my points here. I'm going to rewrite them really quick just so I can label them. So 5, 9, 0, 3. All right, here's my first x and my first y. Here's my second x and my second y. All right, cool. Now we can find our midpoint. Just a quick reminder. Oops. X1 plus x2 over 2 is the first thing we do. So x1 is a 5 plus x2, 0 over 2, comma, doing the same thing with my y's. y1 plus y2 over 2. Be careful with mixing this up with the distance formula. All right, they are, obviously they're different. Cool. From here, we can just do some math here. 5 plus 0 is 5, so I'm getting a 5 over 2. Right. 9 plus 3 gives me a 12, so I'm getting a 12 over 2. All right. This will want you to actually divide these numbers and get either decimals, or like nice clean answers. 5 divided by 2 gives me a 2.5. 12 divided by 2 gives me a 6. So there's your answer. Big thing, if you guys remember, make sure that you are putting parentheses around your answer when you type it into DeltaMath. If you don't do the parentheses, it'll give you a wrong answer. Okay, be careful with that. Okay, so again, go ahead, pause these out. Go ahead and try out some of these midpoint problems, and then we'll move along. All right, moving along. Next thing is the angle addition and subtraction. Take a peek. All right, so this is giving us some angles, giving us some values, and asking us to solve for one of the angles. These are a lot like the segment addition problems, all right? My advice on these, draw the angles that they're giving you here and then put this info on them. Putting the info on the angles makes the problem a lot more easy to understand. So that's what I'm going to do real quick. I'm going to redraw these. Okay, so on your paper, do this with me. So this is point N. We got M, O, and then P. Okay, so let's put this stuff on. So they're asking us to solve for angle MNP. Let's find that. If you guys remember, when we name an angle, we start at its side, go around its vertex to its other side. This is angle MNP. This is what we're looking for. All right, they didn't give us a value for it, so we're just going to call it X. Okay, here's what they're telling us. Angle MNO is 114. You guys notice NMO is the entire thing. All right, so I'm going to change my color. Okay, but yeah, the entire angle is 114. All right, and then you might imagine angle PNO is this one right here. They're telling us is 55. Okay, now that we have this written out, we can see the equation we can make. We know that this small angle plus this small angle equals the entire big angle. Okay, there's our equation. So x plus 55 equals 114. And then from here, just solving for x, getting rid of 55 by subtracting. So I'm just grabbing my calculator, 114 minus 55. Looks like we're getting that x equals 59. Okay, cool. So again, go ahead and put that in, pause the video, try out some examples on this. All right, let's keep moving. So let's see, angles, we got that. This next section, I don't have an example for this, translate figures graphically, because these are really straightforward problems. These are when we start to get into our translations, we're sliding 2 units right, 1 unit up. At least this is my example. Yours probably looks different. Okay, so I think everybody feels comfortable on these. So let's go past that for now, or if you want to pause and try that out on your own, you can. Okay, but I want to get into this next section. Actually, this other one I'm leaving to you as well. Okay, it's kind of the same idea. What translation is going on here? Here's the one thing I want to point out. On my example, yours is going to look a little different. Pay attention to this. How are we translating figure S onto figure T? This is the original, this is the image. Okay, well, on this one, it looks like we're going to the right a certain amount of units and then up a certain amount of units. Okay, that would be my answer here. Okay, so again, I'm going to leave those to you because I feel like they're not too bad. Okay, but my next one I want to do is this translation of a point. Go ahead and go to that. All right, so this one is giving you a point and just asking you to translate 4 units right and 2 units down. All right, so that's the idea. Here, there's a couple ways of thinking about this problem. You could put it on a graph and do the translation that way, or you could remember when we are going to the right, we're going in the positive direction, right? The left is the negative direction. And when we're going down, that's in the negative direction. Up would be positive. Okay, so if I'm thinking about it that way, I am adding 4 to my x value, and then I am subtracting 2 from my y value. Okay, so if I were to add 4 to that and subtract 2 from that, that's one way of thinking about it. So it looks like we're going to get a positive 2 and a negative 9, all right, for our answer here. Okay, so yeah, you can go ahead and put that in. The parentheses are already there for you. Okay, so that's probably the way I would think about it, just using, that typical translation rule. Okay, so yeah, try some of those out. All right, moving on from here, reflection of our figure over a line. Okay, let's check it out. All right, so here is, they want us to reflect over the line of y equals 3. Here's the good news. They are drawing the line of y equals 3 for us. Okay, there's no question as to where that line is, which really takes a lot of the difficulty of this problem away. We're really just asking, they're asking us to just reflect points over this line. Okay, so it's, just as simple as thinking, okay, if this is 1 above my reflection line, I'm going to reflect 1 below. This one's 3 above. I'm going to reflect 3 below. This one's 3 above, reflect 3 below. This one is 1, 2, 3, 4, 5, 6 above, reflect 1, 2, 3, 4, 5, 6 below. Okay, and that's really all these problems are asking for. Okay, so you can go ahead and submit it. Okay, so again, pause the video, try out some of those, and we'll keep moving. All right, so let's see, points reflected over an axis. Take a look at this one. All right, so this problem looks kind of crazy. Okay, let's just kind of read through it. It says point E is located at 3, -5 on the coordinate plane. Point E is reflected over the y-axis to create E prime. Then E prime is reflected over the x-axis to create E double prime. What order pair describes E double prime? What is the coordinates of it? All right, so on these problems, don't let this overwhelm you. We are just doing 2 reflections. All right, the easiest way to do these problems, draw yourself a graph. All right, so off to the side, just real quick, draw yourself an x-axis, draw yourself a y-axis. All right, and I'm just going to do like 5 units in each direction. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, so E is at 3, -5. So that's positive, starting in the center, that's the positive 3 on the x, down to -5 on the y. So here is my original coordinate. Okay, this is E. The first thing they were telling us is that E is being reflected over the y-axis. Remember, this is our y-axis right here. So this thing's going to be reflected over. If it's 3 units to the right, it's going to reflect 3 units to the left, and it's going to end up right here. Okay, so here is E prime. All right, if that's all they were asking for, we'd be done. We'd find the coordinates for that. That'd be our answer. This one wants us to then do another reflection over the x-axis. Here's my x-axis. Okay, and remember, we're reflecting the newest point. This is what's being reflected. So this is 5 units below. I'm going to reflect it 5 units above, and I'm going to get my new E1 right here. So there's E double prime. Okay, the coordinates of this point is my answer. Looks like it's at -3 on the x, +5 on the y. Okay, and that's going to be your answer. Right. So yeah, those problems I think are easiest just with a graph in front of you. If you want to use one that's already in your notes, whatever. Okay, so yeah, try some of those out. Alrighty, so moving along, let's see. Next one, points reflected over an axis. Okay, check this out. This is kind of a new problem. Actually, no, this is one I just did. My bad. Let's see. Okay, reflection of a point is where I'm at. Yes. Wait, I'm like confusing myself. I remember there being a different one. This reflection of a point. No, sorry. Okay, this is what I'm looking for. Sorry, guys. So just so we're all on the same page, go to the class example, identify single rotation or reflection. Okay, so here is the thing. What is going on here is the question. Is it a reflection over y equals -x, y equals x, 180, a rotation, or a 270 rotation? All right, these problems are trying to see if you recognize what certain reflections look like. That, at least that's the focus of these. If you guys remember, the reflection of the line y equals x is this line right here. Okay, and this does not look like a reflection over this line, right? All right, it's not a rotation. So the question is what else is it? Well, it's something we haven't actually put a lot of focus on, but a line that goes from the top left to the bottom right, that is actually the line of y equals negative x. Okay, so if you see this line, all right, that's what the reflection is going to be. All right, again, I'm putting some emphasis on this because we didn't spend a lot of time learning this, but that would be your answer on this one, y equals negative x. Okay, so look out for that. You're going to have one on the test just like that. All righty, cool. So let me see if I can find my spot here. We did that. Okay, reflection of a point. Okay, this is focusing on what we did, spend some time and reflecting over the line of y equals x. All right, if you guys remember back in your notes, this is one of our more simple rules. And the rule was that x comma y, our original coordinate, turned into y comma x. All right, we just swap the two numbers and we have our answer. It's really that simple. So if our original is a negative 1, 7, our reflection is going to be a 7, negative 1. Okay, notice I didn't change any signs. All I did is swap the two numbers. That's how simple those problems are. Okay, so yeah, maybe pause the video, try some of these out. All right, moving on from here, let's look at the rotation of a point. I believe that's where we're at. All right, so these are the ones dealing with our counterclockwise rotations, 90, 180, 270. Okay, make sure these rules here are in your notes and you have them, especially if you haven't memorized them by now. I don't expect you to, so you have them in your notes. All right, so this is asking us to do a 90-degree counterclockwise. So that means we're going to be using this guy right here. Okay, so xy is becoming negative yx. Okay, so if you guys remember, we're swapping our two numbers and then we're changing our original y value. Okay, so let's see what that looks like on this problem. All right. Okay, so, it's just a single point. So, nice and straightforward. So the first thing I always recommend, swap the two numbers to 5, negative 3, and then change your y value. If it's a positive 5, now it's a negative 5. Okay, and it's really that simple. There's my answer. Okay, the big thing I want to point out, I've seen a lot of people make the mistake that when they swap their numbers, they'll then change this negative 3 into a positive 3. Okay, and we are not touching our x when it comes to a 90-degree rotation. Okay, so if it's a negative 3 and you move it, it is staying a negative 3. Don't change its sign because we don't touch the x. We only touch the y when we do a 90. Okay, so be careful with that. Okay, cool. So yeah, there's a bunch of those rotation problems. Take a pause, try those out. If you want to keep this screen up on your computer as you do them, or just have them in your notes. Okay, try some of these rotation rules out. All right, we're getting there. Last couple things, dilation of a point. All right, so this is asking us to just take the point here and apply this dilation with a scale factor of 1/3. All right, if you guys remember with dilations, all we're doing is multiplying by our dilation. The reason why I picked this particular problem is because we haven't actually seen a dilation of 1/3 yet. Okay, but it really doesn't change our problem too much from what we've done in the past. All right, in the past, when we have a fraction given to us as our scale factor, I recommend turning it into a decimal. Here's the weird thing about 1/3. If you guys grab your calculator and do 1 divided by 3, which by the way is how we turn fractions into decimals, we just do the division, 1 divided by 3, we get 0.333, and it just keeps repeating. Okay, so this is what we're multiplying by, though it's not an exact number because it's a decimal that goes on forever. We're still going to multiply by this, and it's going to give us an answer very close. All right, so let me just show you. So grab your calculator and go ahead and do negative 12 times, and then I'm just going to multiply it by 0.333. Okay, if you do that, you're going to get this, negative 3.996, a number that is very close to negative 4. Okay, so that's the idea. We just need to round it a little bit, and I might be overcomplicating this, but I just wanted, just in case you ran into one of these on the test, I wanted to make sure you saw one. All right. So when I multiply this by a negative, yeah, sorry. When I multiply by a 0.333, I get a negative 4. All right, I guess actually that would go down here. Okay, and then when I do 9 times 0.333, I get a 2.997, which is going to round to positive 3. Okay, so that is one way of doing it. I'm doing it this way instead of just multiplying by the fraction because this is how we've done it in the past. But it's kind of strange because of 1/3. Okay, but most of these problems, guys, don't overcomplicate them. Just multiply by the scale factor and you'll get your answer and it'll be really straightforward. Okay, I just wanted to show you a weird one. Okay, cool. So yeah, pause the video, try some of those out. Okay, last thing, dilations on the coordinate plane. All right, so more dilations here. This one is giving us a shape and asking us to, do our dilation by a factor of 1/4. Okay, so there is our scale factor, 1/4. Okay, so this is one of those problems where turning our fraction into a decimal is probably the first thing we'd want to do. All right, if we do 1 divided by 4, we're going to get 0.25. Okay, so 0.25 is what I'm multiplying by. All right. I just want to point out again, I'm purposely picking problems that have kind of strange scale factors. You might get a problem that just says scale factor of 3. Okay, and all you have to do is multiply all your coordinates by a 3. I'm purposely picking a weird one. Okay, so we got quite a few points here. Let's not draw this out too long. So let's go ahead and just get these coordinates. So I'm going to start with G, -4, +4. F 0, 8. Let's see, E is at 8, 4. D is at 0, -8. And C is at -4, -8. All right, so I just need to multiply all of these by my scale factor. So, this is how we normally write it out, times 0.25. All right, grabbing a calculator is the way to do it. All right, so let's go ahead and check it out. So when I go to do G prime, -4 times 0.25 is going to give me a -1. 4 times 0.25 is going to be a +1. Okay, going on to F, 0 times anything is 0. All right, 8 times 0.25, I'm going to double check on that, even though I know I can get it, is a 2. All right, and I think I can probably just go from here without a calculator, but it's never a bad idea to double check. 8 times 0.25 is 2. 4 times it is 1. D prime, 0 times anything is 0. -8 times 0.25 is a -2. And C, -4 times that is a -1. -8 times that is a -2. All right, I did it very quickly. Make sure you just double check with your calculator. Cool, so let's see what it looks like. So when you guys go to tap on these points, -1, +1, it's going to go there. I'm going to just do it on my little board here, but you can tap it on your screen. F prime is at 0, 2. E prime is at 2, 1. D prime 0, -2. And C prime -1, -2. Okay, so after you tap those points, it'll already automatically connect your lines, but it should look like the exact same shape, okay, but a reduction. All right, cool. So yeah, a lot of problems I just went over. Take your time on this, call me over, try some problems out, and make sure your notes have everything you'd like in it to use on the test. All right, everybody, I'll see you.